Okay, so June 2025, P4. Okay, first question, it says, the curve C has equation 2y squared minus 6xy equals to 7e power 2x minus 1 plus 13. The point P with x coordinate half lies on the curve. Find two possible y coordinates of P. So since P has the x coordinate of half, I can substitute this into the equation. So I write the equation first and I replace every x with half. So this x is half and this one is also half. 6 times half is 3. 2 times half is 1. 1 minus 1 is 0. 7 times 1, because e power 0 is 1. 7 times 1 is 7. 7 plus 13 is 20. And actually this is a quadratic equation. This will actually give me two possible solutions for y as stated here. So subtracting both sides by 20. And I can use my calculator. I can use mod53 to get the two solutions for the y. So it would be y equals 4 and y equals -5 or 2. So either y equals 4 or y equals -5 or 2, and there is no any restrictions and he wants to value, so it's okay. Okay, in part B it says, given that P lies above the x-axis, okay. Now it says that P wants the one which lies above the x-axis. So I must use the y, the one which has a positive y coordinate. So this will be the first one, which is half of 4. Okay, and I need to use this finding the equation of the tangent to the curve at this location. Okay, in order to find the equation of the tangent at this location, so I must use y equal mx plus c, where m is the slope of the tangent at the required location P, whose x is half and y is 4. In order to get the slope, I need to find the differentiation of y with respect to x at this location. In order to get this value, I must differentiate this equation with respect to x. So what is the differentiation of 2y squared? It will be 2 times 2 multiplied by y to the power of 1 multiplied by the differentiation of whatever inside the bracket, which is dy by dx. This can be simplified into 4y, and this -6 I leave it as it is because it is a constant multiple. And now I have xy, which is I can perform the product rule, which is first times derivative of the second plus the second times derivative of the first. But the first is x and the second is y. First is x. The derivative of the second, which is the derivative of y, is dy by dx. The second is y. The derivative of the first, which is the derivative of x, which is 1. This is equal to 7 multiplied by an exponential function. So 7 is a constant multiple, so leave it as it is. And differentiating the exponential function is leaving it as it is first, then multiplying it by the differentiation of its power, and then multiplying it by ln of its base. So the differentiation of the power is 2, ln of the base is ln e. So 7 times 2 times ln e is just 14. And now, don't forget my goal. I need to get dy by dx. So let's try to make it subject first. First, I need to expand this -6 here. So this gives me -6 x times dy by dx, and then -6 into y. And now I can make dy by dx subject, but first let's add both sides, or yes, let's add both sides by 6y, and then take dy by dx, a common factor, and then divide both sides by 4y minus 6x. And now don't forget that I need dy by dx at this required location. So replace x with half and y with 4. Okay, this gives me the value of 38 over 13. Okay, so 38 over 13, I replaced it with this loop. Okay, how can I get C if I made it subject? So making C subject, it will be y minus 38 over 13 x. What is x and what is y? It is the x and y of the required point. So replace y with 4 and the x with half. This would give me C with 33 over 13. Replace it. But here I didn't finish. Here he wants this form. And a and b and c are all integers. I'm having some fractions. So I must multiply all the equation by 13. So 13 times y is 13y. 13 times this is just 38. 13 times this is just 33. Now he needs to write x, then y, then the constant number, then 0. So let me move this 13y there, or subtract both sides by 13y, and then rearrange this again. And now I finished the question. Okay, in this question, it says, a spherical ball of ice with radius r is melting. The volume of the ball of ice, V centimeter cube, is decreasing at a constant rate, K centimeter cube per second, where K is a constant. Okay, given that the volume equals to 4 over 3 pi r cubed, show that the rate of decrease of the radius of the ball of the ice with respect to time is inversely proportional to the square of the radius. So I was given the differentiation of the volume with respect to time as negative k here. And I'm given the formula of the volume, which is 4 over 3 pi r cubed. And he wants me to prove or to show that dr by dt will be inversely proportional with the radius squared. So something like this. So first I need to get dr by dt. How can I get dr by dt? If I differentiated everything with respect to time. This equation will be differentiated with respect to time. So the differentiation of volume with respect to time is dv by dt. The differentiation of r cubed with respect to time is 3r squared dr by dt. Let me simplify this. So this is 4 pi r squared. And now let me make dr by dt subject because I need it. And now let me replace dv by dt by negative k, which is a constant. And as you can see, I can write this like this. And as you can see, this is a constant. Negative k is a constant. 4 pi is also a constant. So I can say this is equals to a constant multiplied by 1 over r squared, leading me to say that dr by dt is inversely proportional to the radius squared. Okay, question 3, it says, given that at y equals 4, x will be equals to pi over 6. Solve the differential equation. Okay, in order to solve any differential equation, I must separate the variables. So I must first make the x's in one side. So let's divide both sides by cosine squared to x. And then multiply both sides by dx. Now I can integrate both sides. The integration of y dy will be y squared over 2 plus c, but I will ignore the constant term for now. I'll write it later. 3 is a constant multiple, so let me take it outside. And now, what's the integration of this? You can think in two ways. Whether we use len here, but in order to use len, the denominator's derivative must be written in the numerator. Okay, but the differentiation of cosine squared to x is not just sine to x. So do not think about len. Think about reverse chain rule. Let me rewrite this like this first. So cosine squared downside is the same thing as cosine power negative 2 in the top side. Okay, now let me think. If cosine to x, what's the differentiation of it? The differentiation of cosine to x is negative 2 sine to x. Okay, but I'm not having negative 2 sine to x here. So I can both multiply and divide by negative 2 at the same time. So this will be negative 2, and this will be over negative 2. As if I multiplied it by 1. Okay, now I can apply the reverse chain rule because cosine to x its differentiation is written next to it. It's negative 2 sine 2x. Okay, now I'm having a function to the power of negative 2 and its derivative. How do I perform the reverse chain rule? Imagine if this is invisible. Let's hide this derivative and ask yourself, what is the integration of any function to the power of negative 2? What's the integration of x power negative 2? It's just x power negative 1 over negative 1. Exactly. So replace all of this by x power negative 1 over negative 1. No. Our x is cosine to x. So let's say cosine to x or negative 1 all over negative 1. Let me simplify this. Negative 1 times negative 2 is just 2. And cosine to x will be sent down again. He wants y squared to be subject. So let me multiply all the equation by 2. Or let me first get c because I need it. Let me first get c. So let's make it subject. Oh, I multiplied by 2 first. Okay. When I multiply by 2, I didn't say here true c because it will be just a constant. 2c or c is just a constant that will be found, so I ignore that. Okay, so c here, I can make a subject, so it will be y squared minus 3 over cosine to x. In order to get c, I'll have an initial condition here, so let me replace x with pi over 6, and let me replace y with 4. So I can see that c is 10, and let me replace this. Okay, in exam, how can I make sure that my answer is correct? Actually, if I re-ask myself about this function, okay, I can do a good trick here. The calculator can get me the differentiation at a certain location. So, and also this differential equation can give me the value of dy by dx. So let's get the value of dy by dx from this and check that it's the same from this. Okay, so let's first make y subject. So y will be equal to the positive or negative of the square root of this. Okay, will I choose the positive or the negative square root? If you check here, y is always positive. So I can say that the differentiation of y, which is positive root 3 over cosine 2x, of course my calculator is made in radians, plus 10. Let me see what will this be at any x. So let's choose this one. Let's make x equals pi over 6. So pi over 6. What would be the value of this? Okay, the value of the slope at this location is almost 2.6. Let me check here. Is dy by dx from this equation will also be 2.6? Let me check. So 3 sine 2x all over y cosine 2x whole squared. Let the calculator replace x with pi over 6 and will replace y with 4. So calculate is asking me what is the x will be. I need it to be pi over 6 and I need y to be, yes, exactly 4. So this also gives me 2.6, which is the same exact answer. So this function is certainly correct. Okay, now write f of x in the form of a partial fraction. Okay, this is easy. So this is the function, and you want it into this form. So let me first multiply both sides by this denominator. Let me then expand this. So a over x multiplied those, so x will cancel out, and I will be left with 1 minus x and 2x plus 1. Same thing with b. When trying to multiply b with those, the 1 minus x will cancel 1 minus x, and I'll be left with these two. And in c, 2x plus 1 will cancel 2x plus 1, and I will be left with those, x and 1 minus x. Okay, in order to get a, b, and c, I can substitute x with the values which make these denominators equals to 0. So for example, what makes x 0? If I just substitute x with 0, and here it will be 1. and here it will be -5. So if I substitute x equals 0 in these two sides, this side will give me 5, and this side will give me just a. So a is 5. This is the first thing. Second, I'll try substituting x with 1. So at x equals 1, this side will give me 12, and this side will give me 3b. So b is 4. And then I'll try substituting x with -half, because -half is the value which makes this denominator equals to 0. So substituting x equals -half, it will make this side equals to -6, and it will make this side equals to -3 over 4c. So solving this, I'll have c equals to 8. Okay, a very good way in order to check whether these values are correct or not, we can use the hide property. So what does that mean? Okay, let me write this first and I'll explain it. 17x minus 10x squared all over x multiplied by 1 minus x multiplied by 2x plus 1. Okay, in order to check all of these constants, for example, let's take a. What is the denominator of a? It's x, right? So hide x first. Okay, let's hide x first. And then substitute x with 0. Okay, it will give me 5. So a is 5. Okay, let's try it with b. But first, let me rewrite this like this first. Okay, what's the denominator of b? It's 1 minus x, right? Okay, let's first hide 1 minus x. Like this. And then substitute the x with 1, which is the value which makes this denominator equals to 0. So solve this with 1, it gives me 4. So this is correct. Repeat it with c and you'll find it correct also. Okay, in part B, he wants me to integrate the function that I've just found. Okay, so the integration of 5 over x plus 4 over 1 minus x plus 8 over 2x plus 1. The integration of this, when you have a linear function downside and just a constant number in the top side, you can just say it's len absolute the denominator divided by the differentiation of this linear function. So for example, this 5 is just a multiple, and the integration of 5 over x is len of the denominator divided by differentiation the denominator. So len absolute x divided by the differentiation of x is 1. Same thing here. 4 is just a constant multiple, so I wrote it as it is. And len the denominator divided by the differentiation of the denominator. The same thing is applied here. Do I have plus c? No, I have some limits to be substituted, so let's substitute these limits. First, let's replace x with 4. So len 4 over 1 is len 4. This will be len 3. This will be len 9. Minus substituting this with 2. So minus and open bracket. This is very important. So substitute x with 2. So this is 5 len 2. And then len 1 minus 2 is len 1. So 4 len 1. Actually, this is 0. I'll cancel it later. 8 len 2 plus 1 is just 4 len 5. Yes. Now I need to expand this negative. So negative 5 len 2. Negative times negative is positive. Negative times positive is negative. Okay, and now I asked myself a question. He wants this, or he wants another form. He actually wants some simplified form where he have len 2, len 3, and len 5 only. So I ask myself, what do I do with len 4 and len 9? I can actually simplify them into len 2 and len 3 by this property. Len 4 is len 2 squared, and 2 can be sent here, so it can be 10 len 2. I'll make it later. The same thing in 9, it can be len 3 squared. Minus 5 len 2, len 1 is 0, so I skipped it, and this is minus 4 len 5. Okay, 5 len 2 all squared is 10 ln 2, and this is 8 ln 3, because this 2 will be sent outside here with a multiply sign. So 4 multiplied by 2 is 8. Now I can collect like terms. So 10 ln 2 minus 5 ln 2 is 5 ln 2. Negative 4 ln 3, positive 8 ln 3 is positive 4 ln 3. And negative 4 ln 5 is just written. Now I can make 4 a common factor like this one. So it can be written like this. And ln 3 minus ln 5 is just ln 3 over 5. And that's the answer. Okay, how can I check my answer in the exam? Actually, the calculator can perform an integration step. So let's write this integral, which is 5 over x plus 4 over 1 minus x plus 8 over 2x plus 1. Integrating this starting with 2, ending with 4, this value will be this 1. So is this value equal to this? Let me check. 5 ln 2 plus 4 ln 3 over 5. Actually, it's the exact same value, so I'm correct. Alright, so here in question 5, it says, the curve C has a parametric equations x equal to something and y equal to something in t, which is time. The point P is where t equals 2 lies on curve. Okay, he now needs me to use parametric differentiation to find the equation of the normal. Okay, at the required location P. So the equation of the normal, I can say y equals mx plus c, where m is the slope of the normal at P. So what's the slope of the normal at P? It's negative the reciprocal of the slope of the tangent at P. Okay, how can I get the slope of the tangent at P? It's dy by dx when time equals 2, which is the location of P. dy by dx is differentiating y with respect to x, but here's a problem. I must use a chain rule here because I don't have an equation of y into x. So let me apply the chain rule. Dy by dx is dy by dt multiplied by dt by dx. dt by dx is the same thing as 1 over dx by dt. Let me first get dx by dt. Actually, dy by dt is so easy. It's just negative 2t, so I replaced it here. And dx by dt, let me get it here first. Dx by dt is differentiating this. And in order to differentiate this, I can use the quotient rule. So it's dn dash minus nd dash over d squared, where d is the denominator and n is the numerator. Okay, d, replacing it with 1 minus t, numerator dash, which is the differentiation of the numerator, which is 2 minus n, which is the numerator, multiplied by the differentiation of the denominator, which is negative 1, all over the denominator squared. Okay, let me simplify this. Let me expand first. 1 times 2 is 2t, and minus t times 2 is negative 2t. So this is first 2 minus 2t, yes. And here, negative 1 times 3 times negative 1 is positive 3. And negative 1 times positive 2t times negative 1 is positive 2t. And 1 minus t squared is just the same. 2 plus 3 is 5. And negative 2t plus 2t cancelled out. I now can replace this 1 over dx by dt, which is the reciprocal of this. So it's 1 minus t squared all over 5. And now I can re-simplify this again. So it will be negative 2 over 5t, 1 minus t all squared. Don't forget that I need this when t is equals to 2, which is my required equation. So let's replace t with 2. Yes, here. And now I can get dy by dx, which is negative 4 over 5. And remember, I don't need dy by dx. I need the negative reciprocal of it because I need the normal, not the tangent. So the slope of the normal will be 5 over 4. It's the negative reciprocal of this. And let me replace this here. Okay, how can I get c? I can get C if I made it the subject. So C will be y minus 5 over 4x. Okay, which x and which y? It's the same of this point P. And in order to get y at the point P, I can replace this time with 2. So it will be, yes, it's at time equals 2. So 1 minus 2 all squared, and this will be 3 plus 2 times 2 over 1 minus 2. C will be equals to 39 over 4. Let me also replace this here. Okay, since you want ax plus by plus c equals to 0, but a, b, and c are all integers, so let me first multiply all of these by 4. So this would be 4y, this will be 5x, this will be 39. Let me rearrange this. So subtract 4y from both sides. Let me rearrange this again. This will be my equation. Okay, how can I make sure that this equation is correct? Actually, it's by finding the differentiation using the calculator. Okay, and finding the differentiation using the calculator, I must here write the function y with respect to x, which is not yet found. So let me first find it, and it's actually the requirement of the second question, which is part B. Yes. So he wants me to find the y as a subject, but in terms of x, not in terms of time. So I must eliminate time t. Okay, what is better? Will I make t subject from this equation y, or do I make t subject from this equation? Actually, this equation will end up in a problem because I'll ask myself whether I'll take the positive or the negative root of both sides. There is no any restrictions here, so this is kind of vague or unknown. So let's not use this. Let's make t subject from here easily. So x equals 3 plus 2t over 1 minus t, multiplying both sides by 1 minus t, expanding x. Let's let's move all t's in one side. So subtract both sides by 2t. Then subtract both sides again by x. I can now then take t as a common factor, divide both sides by negative x, negative 2. And now, in order to make this looks better, I can take both common factor -1 from here and -1 from here. Taking common factor of -1 from here, this will look like x plus 2, and this will look like x minus 3. I can now cancel this negative with this one. It looks much better. Okay, now I can replace this t in the y in order to get the y as a subject. So it will be 1 minus t all squared, replace t with this value. Okay, I can now expand these squares, but first, this one, I can make a common denominator. So after expanding this, I can make a common denominator by writing this one as x plus 2 all squared all over x plus 2 all squared. So this will be one fraction. And now I can expand this. Okay, how can I expand a bracket or a binomial squared? It will be the first squared plus the second squared plus the first times second times 2, which is x squared, the first squared, plus the second squared, which is 4, plus first times second times 2 is 4x, minus in the open bracket. The first square is x squared, plus the second squared, which is positive 9. First times second times 2 is negative 6x. Let me then expand this negative, and then take some like terms. X squared cancelled with negative x squared. Positive 4x, positive 6x is positive 10x. Positive 4 minus 9 is negative 5. And now this is y, but all the people forget this. He wants you to get also k. K is the domain of y. And if you check here, x cannot be equals to negative 2. Okay, this is, yeah. X cannot be equals to negative 2. because -2 would lead this denominator to be 0, and this is not possible. Okay, back to the check step. How can I check the first solution A? Actually, I can use the calculator to find the differentiation of y at the required location. If you remember, we asked ourselves to substitute t with 2. So let me do this again. 10x minus 5 all over x plus 2 all squared at x equals something when t equals 2. Okay, let me remember. When t equals 2, what will be the value of x? Let's perform this. 3 plus 4 is 7. 7 over 1 minus 4 is 7 over -3, right? So 7 over -3, oh no, there is some problem. Was t equals 2? Let me remember. Let me actually remember. What was the first question saying? It was asking to get the slope of the normal at some location, right? Yes, it's when x equals it's when t equals 2. Okay, my bad. So when t equals 2, this one will be 7, and this one will be it will be -7, right? So the slope will be -0.8, which is, yes, which is -4 over 5. And actually, I got this value. If you remember, I actually got this with the -4 over 5, yes. Okay, let's continue. This makes me confident. Okay, let's move to question 6. It says write down a vector. Oh, it says write down a vector equation for the line. Okay, what's given about this line? It passes through A and B, and A and B are also given. So this is the line. Imagine this is the line. And this is point A. This is point B. Okay, in order to make the equation of the line, it takes the shape like this. It's R equals to the vector A, which is any point on the line, plus some constant multiple, let's say mu, multiplied by the directional vector AB or BA. It's the same. Or even you can start from B. You can actually write this in too many ways. So all these ways are true and are right. Okay, why actually is this true? Let me explain this in a brief. Actually, what does this equation mean? This equation means that in order to get to some location R, which is, for example, like this one, if you're starting from A, how many multiples of AB you'll move in order to get from A to R? So this is actually the question this equation solving. So in y equal mx plus c, for example, the question is, what is the coordinate of y at some coordinate of x? Or when we are given some x coordinate. Okay, the question here is, how can I get to R by how many steps starting from A in the direction of AB? How many multiples of AB I need to move starting from A? Is it 1 AB or 1.5 AB in order to get to R, or 1.7 AB in order to get to R? This is the question we're asking ourselves. So it's how many multiples of AB I need to move starting from this point, which is A, in order to reach R. So for example, this is 1 AB. If I would start from A, this is 1 AB, and this little thing, let's say, for example, it's 0.4 AB. So actually, I can say that in order to get to R, starting from A, I must move 1.4 units of AB. This is actually the meaning or the core meaning of the equation of the straight line. Okay, now Why this is true for also b plus lambda ba? Actually, because the constant multiple will adjust itself to be true. So for example, starting from b in this equation, starting from b, if I move, for example, 1ba, I'll go to a. Okay, but I don't want to get to a, I want to get to r. So starting from b, how can I get from b to r? Is it if I moved in the direction of ba, or if I moved in the direction of ab? Actually, it will be the opposite. It will be moving in the direction of AB, which is negative BA. So if I move by negative 0.4 units in the direction of BA, I can actually get to R. And that's why I said the constant will adjust itself to be true. Okay, so the equation of the straight line can always be true. Just put a point here, any point on the straight line, and put here any directional vector on the straight line. Okay, let's continue. Let's solve this. So let me replace a with its value. So it's 1, 2, -3. I wrote it in the column vector form. Actually, since the question is written in IJK, I must leave the answer in IJK again. I'll just do it in the last step. All right, so vector AB is vector B minus vector A. Vector B minus vector A is 5 minus 1 in the I, 2 minus 2 in the J, 1 minus 3 in the K. So 5 minus 1 is 4, 2 minus 2 is 0, 1 minus 3 is 4. And this is my straight line equation. I would always start from A, always move in the direction of AB by some constant units. All right. And as I said, I must leave the answer in IJK since it's given in IJK. Okay, now the second question. It says, given also that point C has the position vector something. Okay, he didn't say that C lies on the line. Yes. ABC is forming a triangle, so C is definitely not on the line. It also says that BAC angle is 45. So this angle, yes, this one is 45. Okay, now he wants me to find the exact possible values of alpha. Okay, what's alpha? It's indicating the location of C, but why he's saying values? All right, because C can be on this side of the line or on this side of the line. Yes, actually, this makes sense. So I can have C here, making this 45 degrees, or the other way. Actually, this makes sense. Okay, how can I get C? I can do a product rule. Sorry, yes, a dot product rule between vector AB and vector AC, because the angle between vector AB and vector AC in both cases will always be 45. So I can perform this. AB dot AC equals to norm AB norm AC cosine theta. So AB, I already found it before. It's the directional vector AB here. And AC, I just need to find it. So AC is C minus A. C is 3 alpha K. Minus A is this one. So 3 minus 1 in the I. Yes. Alpha minus 2 in the J. Yes. 5 minus 3 in the K. Yes, like this. All right. This will be like this. Okay, what's the magnitude of AB? It's the magnitude of this one. So it's square root of 4 squared plus 0 squared plus 4 squared. This is 4 root 2. And the magnitude of AC is the norm of this. So square root of 2 squared plus alpha minus 12 squared plus 8 squared. Actually, 2 squared plus 8 squared, I can write it as 68. Cosine theta is of course, cosine 45, which is root 2 over 2. Okay, root 2 over 2 times 4 root 2 is just, okay, I'll do it later. So 4 times 2 is 8. 0 times something is just 0. 4 times 8 is positive 32. Okay, and 4 root 2 multiplied by 4 by root 2 over 2 is just 4, yes. And let me leave this square root like this. Okay, 8 plus 32 is 40. Divide both sides by 4, so this is 10. Let's square both sides, so this is 100. Let's subtract both sides by 68, so this is minus 68, which is 32. Now let's take square root of, but don't forget the positive and negative sign, because actually we have two possible locations. So someone is positive, someone is negative. This makes quite sense. Okay, and now add both sides by 2. So alpha is having two values, which are 2 positive or negative for root. Okay. All right. Now in question 7, it says, show that the substitution u equal to 10x transforms this integral into this integral. Okay, first let's use the benefit of this. Let's differentiate both sides because I need later to transform the x into du. In order to transform the x into du, I must first differentiate or get the x by du. Okay, here I did a trick. So, no, I didn't do anything right now. So the differentiation of 10 is just x squared. It's easy. And now I'm trying to make the x subject in order to replace it later. So the x is du over 6 squared x. Now I can make a very good trick because as you can see, this integral is all in terms of u. So there is no benefit of replacing dx with something in x. So let me replace the 6 squared with 10 squared plus 1, which is the identity. Why is that? Because 10 squared is u squared. I can now, when I replace the x, it will be in terms of u, which is I need. So now let's write this integral and replace every 10x with u. So this is u cubed. 6 squared, as I said, 6 squared is 10 squared plus 1, which is u squared plus 1. Dx is du over this. And as you can see, I can take u common factor up there. And I can now cancel out this one plus u squared and this one plus u squared. I can cancel them out. 4 plus 1 is just 5. And that's the requirement. Okay, how can I check this answer in the exam? Actually, if I perform the integral in the last step in part B. Okay, let me continue. So he wants us to find the exact value of this, which is the same thing of solving this easily. Okay, how can I solve this? Is it ln? No, because the differentiation of this is not this. So I can think about the reverse chain rule. So this can be written like this. What is the differentiation of 5 plus u squared? Actually, it's just 2. Yes, it would be 2u. So how can I get 2u here if I, in the same time, multiply by 2 and divide by 2? So let me write here half, and here's 2. And now let me ask myself, let's hide the derivative and focus on this. What's the integral of some function power negative 3? What's the integral of x power negative 3, for example? Yes, it will be x power negative 2 over 2. So this is half this function power negative 2 over 2 over negative 2, sorry, which is the new power. So simplifying this, it will be half times negative 2, which is negative 1 over 4. And let me write this down. And take care, since the question is written in x, the answer must be also in x. So let me replace this u with tan x again. So this will be the answer. Okay, how can I check this in the exam? How can I check if I'm correct? Okay, let's solve this using any numbers. So let's say tan x plus tan, yes, tan x cubed, sorry. Tan x cubed all over 4 plus sec is 1 over cosine, so 1 over cosine squared all power 3. Let's solve this, for example. Let's do it from 0 to pi over 3, for example. Okay, this will give me this number, 13 over 6400. Okay, let me ask myself, is this function, if I substituted pi over 3 minus substituting 0. Will it be the same? Let's do it. So let's say negative 1 over 4 bracket tan, let's say a squared plus 5 all squared, and then subtracting this, so it will be a positive 1 over 4 tan, sorry, open bracket, tan b all squared plus 5 all squared. And first I'll replace a with pi over 3 and I'll replace b with 0. So let me replace a with pi over 3 and b with 0. Yes, it's exactly the same answer, so I can say I'm correct. Alright, in question 8, it says find the ascending powers of x, the first three non-zero binomial series of expansions, something. Alright. Giving each coefficient as a simplified fraction. Alright. So I can write this like that first, and then this is our negative half because I turned it upside down. Let me take 4 common factors and then expand the power here and there. 4 power negative half and 1 plus 1 over 4x power negative half also. 4 power negative half is actually half. And now I can know the binomial series rule in the formula sheet. It's something like this, where n is the power and x is whatever next to the 1. So let me replace n with negative half, x with quarter x, n with negative half, n with negative half, x with quarter x. And since it just need the first 3 terms, I didn't complete that. So let me simplify this. This would be negative 1 over 8. And this will be negative 3 over 2. This will be 3 over 4. 3 over 4 over 2 factorial is 3 over 8. 3 over 8 times 1 over 4, but take it. 1 over 4 is first square. So 3 over 8 times 1 over 16 is 3 over 1 to 8. And this is x squared. Let me expand this half. So it will be a half times 1 is half. Half times negative 1 over 8 is negative 1 over 16x. And half times this, it will be 3 over 256x squared. And that's my answer. All right. Ignore this. Okay. Sorry. Now in part B, it wants me to get the first 3 non-zero terms, but for this expansion, it's 1 mark question. Since it's 1 mark, it's a 1 mark question, actually, it does not require all these steps I did in the first part. I just stated it in front of you in order to see what is the simple change that I can do to get my answer. Okay, what's the difference between 4 plus x and 4 minus x? This positive x will be positive 1 over 4, but this negative x will be negative 1 over 4. So the real difference is, or will appear here. So this positive 1 over 4, which gave me in the past negative 1 over 8, it would be negative half times negative 1 over 4, which will give me positive 1 over 8. And the same thing here, actually. This negative times negative is positive. Positive multiplied by a positive remain positive. Okay, what now? This negative times negative will be positive. And this negative 1 over 4, since it's inside a square, it will always be positive, and this will always be positive. So I can say that all these terms will be positive. You can see this here. I just wrote it here. This is the real difference is that this 1 over 4x will be negative 1 over 4 here. And the same thing here will be negative 1 over 4. So the real difference is nothing except that this one, which is negative, will be positive. As simple as that. All right, now he wants me to product these two. So these are my results from the previous steps. So I can perform what he said. Okay. And now, all right. Instead of Okay, here is a very good trick. Instead of multiplying these two and writing a very, very long 9 terms, I have a trick to say. Let's regroup this. Let's rearrange this. So, yes, let me rearrange those like this. So I send the negative 1 over 16x there. And the same thing here. As you can see, this term or this group is like exactly like this. And this group is exactly like this. So this red, yes, I colored them in red. This one I colored them in green. As you can remember, I can perform this as the first squared minus the second squared. Okay, why is this true? Because as you can remember, a minus b into a plus b is just the first squared minus the second squared. So this will save some time. Okay, how can I expand something squared? It will be the first squared plus the second squared plus the first times second times 2. Okay, and this would be squared. This would be 1 over 256 x squared. Now I have a like term, so it will be 2 over 256, which will be 1 over 128. And actually, here is a good thing. Why x power 4 disappeared here? Actually, it didn't disappear, but he want an approximated value. And since this number is very, very, very small, 9 over 256 squared multiplied by x power 4. Actually, x cannot be except less than 1 over 4 because this expansion is only valid if x is less than 4, sorry, if x is less than 4. So imagine 9 over 256 squared multiplied by a number which is less than 4 to the power of 4. This will be a very, very small and non-significant value. Maybe that's why he approximated this into 1 over 4 plus this one only. Yes, this makes sense. Okay, now he want me to use this, but now he didn't write approximation, he wrote equal. So he's stating that they are now equal. I can assume this. Okay, so let's say they are now equal, exactly equal. You want me to use x equal to 1 to find something. Okay, let's first replace x with 1. So this x with 1 is root 5, and this x with 1 is root 3. Okay, 1 over root 5 or 1 times 1 over root 3 is 1 over root 15. Okay, replacing this x with 1 also. So this I can use this in benefit of something later. So I can use that 1 over root 15 is approximately or exactly equal to 33 over 128. Okay, he wants me to find root 135. Okay, but here's the thing. What's the relation between root 135 and 1 over root 15? Actually, if you root 135 on the calculator, you can say that it's 3 root 15. Okay, and we have the reciprocal of this. Okay, so 3 times root 15 is 3 times the reciprocal of this. So 3 times 128 over 33, and 3 divided by 33 is 11. Okay, and that's the answer. Okay, question 9. First, it wants me to get the volume of figure 1. So let me apply the rule of volume, which is pi integrated starting from 0 to 4 for this function squared with respect to x. So let me replace the y with its value, and then first squared plus second squared plus first times second times 2. First squared is cosine squared. Second squared is 1 over 25 e power 2x. First times second times 2 is plus 2 over 5 e power x cosine x. Of course, don't forget the x. Okay, but here's a small thing. I have cosine squared x, but there is no cosine squared x here. So I can use the formula that cosine squared is equals to half plus half cosine double the angle. So I replaced it like half plus half cosine the angle, and I just rearrange this to look the same like this. Okay, actually, why this formula works, why cosine squared is equal half plus half, you can read this box and you know why. Okay, now, okay, if you ask yourself, actually, this integral is not hard for half. It's easy for half cosine to x, but this is a big problem. The integral of e power x cosine x, it's requiring some integration by parts skills. This one is easy, so I think that's why he asks this in a separate question to not make you lose some marks. So integrating this by parts, I ask myself, by the word late, is there any len or log function? No. Is there any algebraic expression? No. Is there a trigonometric function? Yes, it's cosine x. So u equals cosine x. And now dv is the rest. So let me differentiate this and integrate this. So the differentiation of u is negative sine x, and the integration of dv is v. The integration of e power x dx is e power x. Now I is uv minus integration v du. So replace u and v by e power x and cosine x. Let me rewrite this. And this will be, sorry, v replace it again by e power x and du by negative sine x. Actually, let me multiply negative by negative, which is positive. And now I am with the same problem. I don't know how to integrate e power x sine x, so I can use integration by parts again. So moving forward, so now I can say that I equals to e power x cosine x plus uv minus integration v du, but now u and v will be those, not those. So uv minus integration v du, uv is e power x sine x, and v du is e power x, du is cosine x. And as you can see, this one is exactly my problem. So I can replace this with I. Yes. I can add both sides by I, so this would be 2I. Yes, exactly. And since I need I, which is this, the value of this integral, I can divide both sides by 2. So this is the value of my integral. I definitely would need that if I would get the volume. Yes. Okay, in part C, he wants me to get the volume of the paperweight, which is double the volume of this one. So as you can see, the volume of the paperweight is 2V, where V is the old expression we had from part A and B. And actually 2 times this, I'll expand the 2 now. Okay, so let's expand the 2. So 2 times half is 1, and so on. I just expanded the 2 here. And now this limits are 4 and 0. Actually, the integral of 1 is x. The integral of cosine to x is half sine to x. The integral of e power x cosine x, I just found it. So I just replaced it. Plus this one, this integral is e power to x over 2. Substituting this with 4, then subtracting this from 0, the answer became 290. Okay, actually, how can I check this in my exam? Actually, I can let the calculator do it for me. Pi integral 1 plus cosine to x plus 4 over 5 e power x cosine x plus 2 over 25 e power 2x, close the bracket. The integration is from 0 to 4, and to 3 significant figures, no, to 2 significant figures, it's 290. Yes, I'm correct. Last question, question 10. Use proof by contradiction to show that for all angles x where x belongs to or lies between 90 and 180, cosine to x over cosine x minus sin x, the modulus of that will always be less than 1. Okay, let's first assume the opposite. So let's first assume that, sorry, 1 second. So let's assume the opposite. So assume that for all the angles x, where x is in this region, that this inequality will be having the exact opposite meaning, which is big greater than or equals to 1. Okay, now let's solve this inequality and try to find a contradiction while solving it. So cosine to x, I can rewrite it as cosine squared minus sine squared. I can factorize this into a difference between two squares. So this one is just like this one, so I can cancel them out. And now, how can I find a contradiction to this? Okay, first, let's remove the modulus. Let's get rid of the modulus. So if modulus something is greater than or equal to 1, this means that this something is either greater than 1 or less than -1. Okay, first let's try to find a contradiction in this statement. So in cosine x plus sine x greater than or equal to 1, how can I find the contradiction in this statement? Actually, it took me a while to think this or to figure this out, but I focused on this range. Since x is between 90 and 180, this means that x is this in the second quadrant. I mean by that the sine values will always be a positive value, and the cosine values for x will always be a negative value. So I wrote this here. Since x is between 90 and 180, so sine x will always be greater than 0, and cosine x will always be less than 0. And actually, I can now see a contradiction. Why is that? Because if you try to make the sine subject here, so subtract both sides by negative cosine, actually, this cosine is a negative number. And 1 minus a negative number is 1 plus a positive number. And you know that sine x can never be greater than 1. This is impossible for any value of x. So that's a contradiction. This is the first thing. Now let's analyze this one also. It will be exactly the same actually. So trying to find the contradiction in this one. So cosine x plus sine x less than or equals to -1. If you try to make cosine x subject, sine x is always a positive number in this range. So -1, negative a positive number, you're saying that cosine x will always be less than -1, which is impossible for any value of x. So this is also a contradiction. So for all the angles x between 90 and 180, this condition must be true. Thanks for watching.